हेलो एवरीवन, वेलकम टू द चैनल। हमारा आज का टॉपिक है कैलकुलस। और कैलकुलस के दो बेसिक पार्ट्स होते हैं, वन इज डिफरेंशिएशन एंड द अदर वन इज इंटीग्रेशन। सो आज के वीडियो में हम डिफरेंशिएशन के बारे में डिस्कशन करेंगे। सो बिफोर स्टार्टिंग द टॉपिक दैट इज डिफरेंशिएशन, we need to understand what basically is calculus. डिफरेंशिएशन और इंटीग्रेशन कैलकुलस के दो ब्रांचेस होते हैं, बट व्हाट इज कैलकुलस? स्टडी ऑफ चेंज। किसी भी बदलाव की स्टडी को हम कैलकुलस कहते हैं। कोई भी चेंज हो उसे हम इस दो फॉर्म में स्टडी करते हैं एंड दैट इज नोन एज कैलकुलस। नाउ area is equal to pi r. This is just a general formula. As we can see, r here is the radius, a is the area, and this is pi, which is a constant over here. So now we can make out that if there is any change in the value of r, a automatically has to change. If the radius changes, the area has to change automatically, and the pi is a constant, pi does not change. So with the help of this relation, we can say that r is our independent variable. R is independent because उसको area से कोई फर्क नहीं पड़ रहा है. Area is changing because of change in radius, but radius is not changing because of a change in area. And area is changing, so it is known as our dependent variable. Now we can make a definition about what is function. What is a function? So function is nothing but it's just a relationship between this dependent variable and an independent variable. It is a relation between a dependent variable and an independent variable. Now, with the help of this formula, we can write that A depends on R, okay, or we can also write A is related to R, and mathematically it is written as A is a function of R. That means A depends on R. Mathematically we write A is a function of R, and symbolically it is denoted as A is a function of R. Now, let's get back to the topic, which is differentiation. So, before that, you all might be knowing that differentiation is denoted by dy upon dx. This is nothing but the rate of change of y with respect to x. x में जो भी changes है उसका y पे क्या effect है, that is known as differentiation. It is denoted as dy by dx. Now, what is the geometrical significance of dy by dx? Geometrical significance. Now, if we plot a graph on an xy plane, let the graph be a upwards parabola. Now, if we have to find the slope of this parabola, we can do that by the help of dy by dx, and that is only the geometrical significance. What we have to do is connect a tangent from the origin passing through the graph, the point. Let's say this is point P. The point of intersection is point P. Now, the slope which is touching the point will have an inclination of theta. Let's say the angle is theta. Now, if we differentiate this theta in terms of dy by dx, y is the y coordinate and x is the x coordinate of the graph. If we differentiate theta in the form of dy by dx, we'll get the slope of the tangent. इस स्लोप का जो भी स्लोप है इस टेंजेंट का, जो भी ग्राउंड से इंक्लिनेशन है, that will be given by differentiating the theta, and that is only the geometrical significance of dy by dx. It gives the slope of a tangent. Now, some mathematical formulas for differentiation. First, dy by dx. Now, whatever values here will be differentiated in terms of y. We denote it as dy upon dx, and whatever the value will be here to be differentiated, that will be the value of y. So let's write here for values of y. First, dy by dx, that is equal to d by dx, and in place of y, let's say we have x to the power n. x to the power n का differentiation करना है हमें, जो कि y की place पे है. So there is no derivation or anything, it's just the basic formula to remember. X to the power n का differentiation is x to the power it is nx to the power n minus 1. जो भी x का power है, that will shift to the coefficients place of x, and whatever is the power will be subtracted by 1. X to the power n is equal to nx to the power n minus 1. Second, dy by dx, and in place of y, let's say we have sin x. So sin x का differentiation is nothing, it's cos x. Third, dy by dx, that is d by dx, and let's say we have cos x. Now the differentiation of sin x is just cos x, but the differentiation of cos x is not just sin x, it's negative sin x, minus of sin x. Fourth one, d by dx ln x. Again, there is no differentiation derivation, it's just a basic formula. that is 1 upon x. ln के साथ जो भी वेरिएबल होगा that is shifted to the denominator's place and the numerator's place is 1. It is divided by 1 and this is the differentiation of ln x. Fourth, dy by dx e to the power x. Now this is an important part. E to the power x का differentiation is e to the power x. There is no change in the differentiation of e to the power x. It remains as it is. Sixth, dy by dx constant. If there is any constant value, कोई भी constant value, let's say 0, 1, 2, a, b, c or any constant value, the differentiation is 0. कोई भी constant further differentiate नहीं हो सकता है. Next, seventh, dy by dx, that is d by dx and let's say root x. The differentiation of root x is nothing but 1 upon 2 root x. Next, d by dx let's say tan x. The differentiation of tan x is sec square x. And the last one, which is dy by dx, that is d upon dx and let's say sec x, that is sec x dot tan x. Sec x का differentiation is nothing but sec x multiplied by tan x. Now on the basis of these formulas, let's take up some questions. Question number 1. Y is equal to, let's say 5x plus 4 whole cube. Now this is the value of y and so we need to, you can see that y here is a function of x. That means the y need to be differentiated in terms of x. Y has to be differentiated only and only in terms of x. So we can write dy by dx, that is d by dx, and place of y we have 5x plus 4 to the power 3. Now if you remember the formula, this is in the form of x to the power n. This is x to the power n and we know the differentiation of x to the power n, that is nx to the power n minus 1. So this is n over here. So let's take this in the coefficients place. So it will be 3 multiplied by x, that is 5x plus 4, and this is n minus 1. So 3 minus 1. So we can write it as 3 multiplied by 5x plus 4 whole square. But this is not our final answer. This is an incorrect answer because in the final step we have to multiply the answer by the coefficient of x. In each and every formula, the answer is incomplete if we do not multiply the final answer by the coefficient of x. So this is the final answer. We can simplify it further as 15 5x plus 4 whole square. This is the absolutely right answer. Question number 2. Y is equal to root 5x plus 4. Now, as you can see, this is in the form of root x and this is in the form of a constant. So we can write dy upon dx, which is equal to d upon dx, and in the place of y we have root 5x plus 4. Now, we know that a constant cannot be differentiated. The differentiation of a constant is 0. So we can directly eliminate 4 from here, and we know the differentiation of root x, that is 1 upon 2 root x. Now in place of root x we have root 5x over here. So we have to do nothing, just d upon dx, and the differentiation of 5x would be 1 upon 2 root 5x, and in the end we have to multiply the equation by the coefficient of x, that is 5. So this is our final answer. Next question. Let's say y is equal to sine ax plus b. Now if we assume this entire term as x, then it is sine x, and we know the differentiation of sine x, that is cos x. But we have to prove it over here, that is y is equal to d by dx, that is equal to d upon dx, and here we have cos ax plus b, and still this is not a final answer because we have not multiplied the coefficient of x with the final answer. So our final answer will be cos ax plus b, that is cos x, multiplied by the coefficient of x, that is a. This is the right answer. Next question. Y is equal to e to the power ax plus b. Now we know that this is in the form of e to the power x, and the differentiation of e to the power x is the same, that is e to the power x. So d upon dx e to the power ax plus b, that is e to the power ax plus b as it is, multiplied by the coefficient of x, that is a, and hence this is our final answer. Next question. Let's say y is equal to ln x. So d by dx ln x, that is 1 upon x. Now if we add some values, we can take it as y is equal to ln ax plus b. Now we have to assume this entire term as x. Now we can just solve it. D upon dx ln ax plus b, which is nothing but 1 upon x, and here in place of x we have ax plus b. But still this is not the final answer because we have to multiply the coefficient of x in the final step. So we can write 1 upon ax plus b multiplied by a, and this is our final answer. Now, there's one question that is 6t cube. Now, there are two ways to differentiate this. First is our original method, that it is in the form of x to the power n, and over here 6 is not a constant. 6 is not a constant because it is attached with a t over here. So 6 will remain as it is, and this t will shift to the coefficients place of t, that is 3t, and n minus 1, that is 2. So if we open the brackets, we can simplify it as 18t square. And the next method we have is if we take this 3 over here, let's ignore this 6. If we take this 3 over here, that is nx to the power n minus 1. So this is n x to the power n minus 1, that is 3t square, and then we multiply this 6. So the answer is ultimately the same, which is 18t square, but the thing over here is, in the first method, we took 6 out in the first step. That is, we took out 6 and then differentiated t cube. And in the next step, first we differentiated t cube and left 6 as it is. And in the final step, we multiplied it. So both ways are the same, but the difference between the two is this is used when we are dealing with the chain rule. Now, what is chain rule? Now, there are many equations or many formulas which cannot be proved. There are many differentiation questions which cannot be proved just by the help of those mathematical formulas. We have to use a rule called chain rule in order to differentiate those questions. And while using the chain rule, if we have to differentiate 6t cube, this is the method which is going to help us, and this method will fail sometimes. So, let's start with the chain rule. Now, let's start with a question. D upon D, let's say y is equal to ln ax plus b. Now, we all know the mathematical formula to answer this is 1 upon ax plus b multiplied by a. This is the formula based answer. But now we have to prove this by the help of chain rule. So, this entire term over here, which we assume as x, we have to assume it. Now, let us say t this time, not x, let's take it as t this time. So, now the equation is something like y is equal to ln t. Now on one side we have to differentiate this t. एक कॉर्नर में हमें t को डिफरेंशिएट करना है, दैट इज the value which we have assumed as, and in the next side we have to differentiate the value which we have assumed. इधर हमने t assume किया है, सो हमें t को differentiate करना है, और इधर हमें उस चीज को differentiate करना है जिससे हमने t assume किया है. So the equation is something like ln t, and over here we can write t is equal to ax plus b. So now it must be clear, इधर हमें t को differentiate करना है और इधर हमें ax plus b को differentiate करना है. So the differentiation of ln t is nothing but d upon dx, that is 1 upon t, and this is, you can see over here that t is a function of x. So this means that this time we will not differentiate y with respect to x. This time we will differentiate dt upon dx. That is d upon dx, and in place of t we have ax plus b. Now b is alone, that is a constant, so we can directly eliminate, and a or x, no one is a constant over here because they both are attached to each other. So if we take a outside, can we write it as a d upon dx, and we have this x inside, and if this d is multiplied by this x, we can write a dx upon dx, and ultimately these two dx will cancel out each other. So in the final equation, can we write dy upon dx multiplied by dt upon dx, I'm sorry, this is y as a function of t, you can see y is a function of t, so this will also be differentiated in the form of d upon dt. So this is for the value of y, so dy upon dt, and this is dt upon dx, that is the value of dy upon dt is 1 upon t multiplied by the value of dt upon dx, that is a. This dt will cancel out each other, and our final answer is dy upon dx equal to 1 upon t multiplied by a. Now in the beginning we assumed ax plus b as t, so we'll have to just put the values of t, that is ax plus b, and this is multiplied by a. Now this is the derived answer, and this is a formula based answer. This is a, this is a formula based answer, and this is our derived answer. You can see that both the answers are matching. 1 upon ax plus b multiplied by a, 1 upon ax plus b multiplied by a. So we can write, hence proved, that this is the absolutely correct differentiation. Next question. Question number 2. E to the power 5x plus 4, let's say y is equal to, and we know the differentiation of e to the power x, that is just the same e to the power x, and we have 5x plus 4 over here in place of x. So this is completely formula based. Now we have to derive this using the chain rule in order to prove that this is the correct differentiation. So according to chain rule, we have to assume this term as one single variable. So let's say this is equal to t. So t is equal to 5x plus 4, and the equation will now look like e to the power t. So as I said earlier, we have to differentiate both. हमें t को भी differentiate करना है जिसे हमने assume किया है, और हमें 5x plus 4 को भी differentiate करना है जिसे हमने assume किया है. So you can see over here t is a function of x. So dt upon dx, we have the values for t. So d upon dx 5x plus 4, and over here we can write y is equal to e to the power t. So you can see that it is y as a function of t. So we can directly write dy upon dt. We have the values for y, that is d upon dt e to the power t, and the differentiation of e to the power t is e to the power t. So we have one answer over here, that is dy upon dt is equal to e to the power t. Now over here you can see this 4 is a constant, so we have directly eliminated this, and 5 is not a constant because it is attached with the x over here. So if we take this 5 outside, can be written as 5d upon dx multiplied by x, and if this d is multiplied by this x, we can write 5 dx upon dx, and ultimately this dx and dx will cancel out each other. So for a final equation we have dt upon dx multiplied by dy upon dt, that is equal to, the answer of dt upon dx was 5 into dy upon dt was e to the power t. This dt will cancel out each other. We are left with dy upon dx 5 into e to the power t, that is, we assume t as 5x plus 4. So e to the power 5x plus 4. So this is the final answer, and it is proved that e to the power 5x plus 4 multiplied by 5, this is the derived answer and this is the formula based answer, and I left out a 5 over here. I said the final answer has to be multiplied by the coefficient of x, that is 5. So this was a formula based answer and this is a derived answer, and both are same, and hence we can write proved. So this is the absolutely correct differentiation of e to the power x. Next question. Question number 3. Y is equal to sine root 5x. Now, we know the differentiation of sin x. Sin x का differentiation is nothing but cos x. But over here we have this root 5x. So let us assume this, let's suppose, as t. So now the equation will look like y is equal to sine of t, sine t. And over here we can write t is equal to root 5x. So first of all, differentiating this corner, we have d upon dx sine t, that is cos t, and over here t is equal to root 5x, and in order to eliminate this root, can we take t is equal to root u? If for a while we ignore this root 5x, can we take this root 5, this 5x as a variable? Now if we suppose this 5x as a variable, this root cannot be ignored. So it will be root of u, not u, because we are just taking 5x, we are ignoring the root. So if we take a new variable, it will be equal to root u, not just u. So it will be dt upon du, and we have the value for t, that is root u, and we know the differentiation of root u, that is 1 upon 2 root u. Now this has to be differentiated one more time because still we have this root over here. So as we can see, t is equal to root u and t is also equal to root 5x. That means both of them are common to t. So can we write root u is equal to root 5x? Yes, because both are the values of t. T is definitely equal to t. So that's how we can write root u is equal to root 5x. Now taking the roots as common, we are left with u is equal to 5x. Now this has to be differentiated and this is the last step to get the final answer. So we can write du upon dx, that is d upon dx, and in place of u we have 5x. Again taking this 5 outside, we are left with 5d upon dx. This is multiplied by x. So our final answer for this differentiation is 5. Now we just have to write the final equations, taking all the values of these three differentiations. So dy upon dt, which is this, multiplied by dt upon du, multiplied by du upon dx, which is this, and now we just have to keep on putting the values. Dy upon dt was cos t, multiplied by dt upon du, which is 1 upon 2 root u, and du upon dx, which is nothing but 5. So this dt and dt will cancel out each other. This du and du will cancel out each other. So we are left with dy upon dx is equal to cos t multiplied by 1 upon 2 root u into 5. And we have to put the values of t, that is root 5x, which we assumed in the beginning. So we have the final answer as cos root 5x multiplied by 1 upon 2. Now this is root u. Root u is equal to t and t is equal to root 5x. Root u is equal to root 5x and not just 5x. This is root with u, so it will be equal to root 5x. So 2 root 5x multiplied by 5, and this is our final answer. Now this had to be proved by the help of chain rule because we just have the formula of sin x. We do not have the correct formula for sin root 5x. So in this case the formula method fails. We have to use only and only the chain rule in order to differentiate such questions. Now let's take one more question. Question number 4, that is y is equal to ln root sin theta. Now we know the differentiation of ln x, that is 1 upon x, but there is no such formula for the differentiation of ln root sin theta. So we have to use the only and only the chain rule in order to differentiate this. So again the same process. Let's assume this entire term as t. So now the equation is something like y is equal to ln t, and over here we have t is equal to root sin theta. Now we cannot differentiate the sin theta with a root over here. So we have to somehow eliminate this root. So to eliminate this root, we have to differentiate this 2 times. So can we write t is equal to root u? ignoring the root, we are just supposing this sine theta as a new variable, that is u. Just ignoring the root. Sine theta is equal to u, let's say, and root is common, so we'll add the root to u as well. So this is t a function of x, so sorry, t a function of u, so d upon du, that is root u, that is the value of t, and we know the differentiation of root u, that is 1 upon 2 root u, and the third differentiation. Now as you can see, t is equal to root u and t is also equal to root sine theta. Both are the values of t, that means both are equal to t. So can we write root u is equal to root sine theta, because both are equal for the values of t? Yes, root u is equal to sine theta, we can write this. Now taking the roots as common, we are left with u is equal to sine theta. You can see over here that u is a function of theta over here. So we can write du upon d theta sine theta, that is d upon d theta. We have the value of sine theta in place of u, that is nothing but the cos theta, the differentiation of sine theta. So in the final step, we have to substitute the values of all these three equations to get the final answer. So over here we have left this one, d upon dt ln t, which is differentiated as 1 upon t. So dy upon dt multiplied by dt upon du multiplied by dA upon d theta. Now we'll write the values, that is 1 upon t multiplied by 1 upon 2 root u multiplied by cos theta. Now this t and u will cancel out each other. Now we are left with dy upon d theta. Now this time we are not left with dy upon dx, because it is clear in the question only that we are required to differentiate y with respect to theta. There is no x on the RHS side, so y has to be differentiated in terms of theta. So that means we are absolutely correct till this step. We have got dy upon d theta, and we just now have to substitute the values of t and u. So 1 upon t, that is root sine theta, that is t, multiplied by 1 upon 2 root u, and root u is equal to root sine theta, and ultimately cos theta. Let's check it. 1 upon t, that is 1 upon root sine theta, 1 upon 2 root sine theta, and cos theta. So this is the absolutely correct differentiation. Now we have a last topic left under this differentiation, that is function with respect to new variable. Now what does this line mean? Function with respect to new variable. Let's understand by the help of a question. Let's say y is equal to root x, and we are asked to find dy upon dz. Now as you can see, this is y as a function of x, and we are asked to find dy upon dz. We do not have a dz over here, we do not have any z over here. So in order to solve this, we have to use a concept known as variable shifting. Now what is variable shifting? This is dy upon dx. So we have to differentiate only and only in form of dy upon dx. But we have dy upon dz. So first we'll write dy upon dz as it is, and for the place of y we have root x. So we can write it as d upon dz root x. Now as you can see, we have to differentiate this x, and here we have dz. So in no case can this be differentiated. So we have to multiply this entire part by dx and also multiply it by dx. So now we have dx and dx. So now comes into play this variable shifting, that is we shift the denominators of both the parts. So now we have d upon dx which is shifted over here. We have root x to be differentiated, and this dz will go over here. So we have dx is as it is, dx upon dz. So this is dy upon dx with respect to x, and we know the differentiation of x, that is 1 upon 2 root x and multiplied by dx upon dz. So this is a final answer for the case of a different variable or a new variable. Let's take one more question. Let's say y is equal to sine theta, find dy upon dz. Now all of us know that over here y is a function of theta. So this can only and only be differentiated in terms of dy upon d theta, but we have dy upon dz. So first of all we'll just write it as dy upon dz, and in place of y we have sine theta. Now this is theta to be differentiated, and we have a z over here. So in no case can this be differentiated. So we have to use the variable shifting again. That is, we multiply this entire part by d theta and also divided by d theta. Now the shifting of variables, this will come to this side and this will go here. So we are left with d upon d theta sine theta multiplied by this d theta will remain as it is, and this dz will shift over here. Now this is dy upon d theta, and we know the differentiation of sine theta, that is nothing but cos theta and multiplied by d theta upon dz. So this is our final answer in the case of a new variable. So that's all for today. Hope you liked the video. Thank you.